Hey everyone, how's it going? In today's video, we'll be looking at this problem that is called 2sum. And this belongs to an entire category of questions, which is like 2sum, then you have 3sum, and then you have 4sum. And 2sum being the easiest one, I decided to do this one first. So let's understand the problem and see what it asks us to do. So it says, given an array of integers, return the indices of the two numbers such that they add up to a specific target. So what you're doing here is that you're given an array of integers, you're also given a target value, and you have to find two integers from inside this array that will add up to this given target value. So a very naive way to approach this problem would be to simply scan all the possible pairs, and that will be an n² time algorithm. So that will be pretty slow. And what you're expected to do here is that you are expected to find a linear time algorithm to solve this problem. So how will you do that? So a very nice way to think about this is that you're just required to find two numbers, and if you found one of them, you already know which is the second number that you want to look for. So what do I mean by that? So taking an example here, the target that you're given is 9. So when we're scanning the first element, for example 2 in this case, you already know that the second element that you're looking for is 7, which is basically the target value minus the current value. So it will be 9 minus 2, that is 7. Similarly, in case the target value was, let's say, 5, so you'll be scanning the first element, 2, you know that the other element that you'll be looking for is going to be 3, right? So in that way, you'll know whichever is the second element that you're looking for, which in this case will be 7. So it will be nice if we could somehow keep track of all the elements that we've seen till now. And in case we have already seen that complement element before in some place in the array, that will be quite fast to find that element, right? So we'll already know that, okay, we've already seen the complement and we have the current element. So let's just return these two, right? So that is what we'll be doing right now. And how do we look those elements up? How do we store those elements, the elements that we've seen till now? We'll use a hash map for that, right? So how do hash maps work? They work in constant time. They are constant type lookups and constant time insertions. So that is really fast and that is really efficient, and that will allow us to make an O of n time algorithm, right? So let's just take another example here. Let's say I've been given an array that is something like maybe 2, 4, 5, 0, 1, and maybe 34, right? And the number that you're supposed to look up, that's a target sum that you're already given, is 39, right? So if you try solving this with the naive approach, you'll first be making all the pairs with the number 2, then all the pairs with the number 4, then all the pairs with the number 5, and it'll take quite a bit of time. And the approach that we're going to use now, which is a linear time approach, it will take the advantage of the hash map, which will store all the already scanned elements, and it'll allow us to look up the complements of each of those numbers. So what we'll do here is, I'll just write that target equal to 39. So how we'll iterate over this entire array would be, we look at 2, and currently the hash map, I'll just create another entry for the hash map so that we can keep track of what all elements have we seen. So we iterate over the current element, which is 2. We find the complement of it with the target, which will be 37. So we'll say, do we have 37 in the hash map? We said no. We say, all right, let's just move on and add the current element to the hash map, and we'll add 2. Then we look at the second element, we look at 4, and we'll say the target value here is 35. Do we have that in the hash map? No, we don't. So we move forward and just add the current element to the hash map. Then we look at the next element, which is 5, and we say, do we have 34 in the array, in the hash map till now? We'll say, no, we haven't encountered 34 yet. So we'll just add the current element to the hash map and move forward. Similarly with 0, you'll say, do we have 39, which is the complement, 39 minus 0 equal to 39. So you'll say, is 39 present, or have we encountered that till now? We'll say, no, we haven't. So we'll just add 0, the current element, move forward. We'll check 2. We'll say the complement is 37. Have we encountered that in the hash map? We have not. We'll again move forward, and we'll simply enter 2 here. And then we'll come to the last element, which is 34. We'll say the complement is 39. So the complement is 5, which is 39 minus 34, which gives us 5. We'll say, do we have that in the hash map? And using the constant time lookup, we'll already know that yes, 5 was present in the hash map, and we'll say this is a successful case. So let's just return the indices of these two elements, right? And hash maps allow you to store key value pairs. So you can store these values that you've encountered as keys, and the mapped values for them will be the indices, right? So let's see how we'll do that. I'll just remove this up and let's just start coding it out. And I'll be using C++, and hash maps are implemented as unordered maps in this language. So I'll just do that. And I'll be having integer keys and integer values, and I'll name this as MP. Now all you need to do is iterate over the array. So for int I equal to 0 while I is smaller than nums.size and plus I. Now the first thing that we need to do is find the complement of the current number that is being scanned. That we'll do is, so what we'll do is we'll let int complement equal to the target minus nums I, and now we'll check if we've seen this if we've seen the complement of the current element till now in the hash map. So for that we'll write an if condition. If mp.find, which is used to find an element in the hash map, and we'll send in complement. If we have the complement, then it'll return a non-null value, and if it's not present, it'll return an iterator to mp.end. So that will be a null case, and in case it is equal to mp.end, it will mean that it is not present in the hash map, and it will not run the if condition, and it will be false, and we'll just skip this. And in case it's found, then we will simply enter the if condition and return the answer. So I'll return an array that I'll generate on the fly, and I'll send back the indices with the index of that element, which I'll be storing as the mapped value. So I'll write mp and complement comma I, which is the index of the current element. And in case it was not found, all I have to do is simply add the current value. In case that return condition did not run, I'll just enter the current element being scanned into the hash map along with its index. So I'll just write nums I equal to I, and that should be it. And just to avoid the warning that the compiler might sometimes give you because you have not returned anything at the end of the function, so I'll just return a dummy value, which will be -1, -1, right? So this should be it, and I'll just try running this, and it runs. So we'll just submit this, and it should be a pretty fast solution. And it runs in 12 milliseconds, 94%. That is pretty nice, right? So this is how you do this problem. If you like this video, just hit the like button. If you want to see more content, just subscribe to this channel and check out the other videos as well. I make content almost every other day, so be sure to look out for that, and I'll see you in the next video.